So this is kind of the heart of what I'm installing. It's the Victron Multi Plus 2, 24 volt, 3000 watt. It is the 2 times 120 volt input, so it can handle both legs of the 50 amp shore power. I'm going to add a MPPT charge controller and solar to the roof. This converter right here will allow me to run all of the 12 volt accessories off of the 24 volt batteries, and I have two of these 230 amp hour 24 volt lithium ion batteries that I'll be using. So the trick is to see if I can get all this stuff to fit in the basement and get everything wired up. Here's the overall diagram of what we put together. You can see the Multi Plus 2 up there in the top left quadrant. That gets AC input from shore power, shown by that green cord in the center. That can be 20 amp, 30 amp, 50 amp, really doesn't matter. The power watchdog is in there to ensure that you're getting good clean power, and it will prevent any significant voltage spikes and protect the rest of the system. AC output goes through a combiner block. In case I want to add another multi-plus, I can add two and it'll combine them into the one output to the breaker panel, which is in the lower left-hand corner of the screen there. From the from the DC side, we've got the two lead-time lithium-ion batteries, 24 volts, 230 amp hours each. Those are fed into the bus bar on the positive side, which contains several fuses off to the various other devices. On the negative side, they both combine into a shunt, which goes into a negative bus bar. The other 24 volt components include the MPPT solar controller, and that is kind of the center blue box there on the right side. That'll go to a solar shutoff switch and then up to the solar panels on the roof. There is also a 12 volt converter which will bring in truck power, and that's where you see the picture of the truck on the lower right hand side. And then there's the 24 volt to 12 volt converter, which is the little skinnier one there in the lower left of the blue boxes. That'll go through some breakers and then eventually into the 12 volt side of the fuse box. So let's go ahead and take a look at what the installation will look like. Okay, let's look at what we're starting with. I'm crawling up into the basement here, and we have our 1000 watt power inverter. This powers the refrigerator. I think the TV's plugged into that as well, and so that's what allows us to run those things off the battery. Here's our power converter, and this charges the batteries. This runs off of the 110 coming in off of shore power, and that's the hardwired Hughes power watchdog that I installed a little while back. So we'll pull this stuff out of here and see how much room we've got to install as much of our new system under here as possible. Okay, here we are with the inverter and converter removed. Got a little bit of space to work with. This is what ran out to the fridge and the TV circuits. So what I'm going to do is I'm going to pull this into the back of the existing breaker box inside the camper and add a fuse to the main panel. Add a breaker to the main panel for the fridge, and that'll run off of either shore power or inverter power, just like everything else. Since the concept of having the new inverter is to power everything, we don't need that dedicated circuit anymore. So I will get that rerun, and we'll take a look and see what we can fit in here and go from there. Okay, got quite a bit installed. We'll start with the bus bars up here at the top. I've got the negative bus bar for all the grounds, and those route through the shunt, which will go to the negative of both batteries. We've got the positive bus bar that has the large fuses. It starts with what's going to be coming in from my battery on-off switch, and it's a battery combiner, so basically I can plug each battery into a different pole on that switch and either do one battery, both batteries are off. So both batteries will feed into this end of this bus bar. And then I've got 4 fuses. First one is for the solar MPT controller. Next one is for the power converter. Got an opening there because I wanted to put the multi-plus on the end. So there's a big 300 amp fuse going to our multi-plus over here. I also have the AC in hooked up on the multi-plus. That's coming straight from the power watchdog over there. Still have to do the AC out. The line from the breaker panel inside wasn't long enough, doesn't reach. So I got to do a breakout box for that, which I was kind of planning on anyway to make it expandable for a second multi-plus. And talk about that a little bit more later. Over here you can see where I have the solar controller and the power converter mounted. So for the power converter, I was able to reuse the 4-gauge cables that were already routed up to the front for the old inverter to go directly to the batteries. So those were already routed under the floor, and I just took that positive 4-gauge, went into here, and then the ground up here. Now that particular power converter is not isolated, so it's going to be a shared ground between the 12 volt and the 24 volt systems. And so I've got, as you can see up here, I've got one 4-gauge ground going to that power converter, but I've also got, and I don't know if you can see it back there or not, but there's some chassis grounds that I've got that run into as well. And that way I can just pick up that ground up front for the 12 volt system, or at least the hydraulic pump. Talk real quick about this 10-gauge wire. I fished that all the way through to the front because that is going to be the power converter that works the other way and takes 12 volts from the truck and provides 360 watts of charging into the system. So since that's only 15 amps on the 24 volt side, I just went with a 10-gauge wire and a 30 amp fuse. That'll be enough for me to double the converter if I need to. All right, so that's where we're at so far. We have everything hooked up front. So you can see the batteries, old batteries are gone. I do have some holes to plug where the vents were here on the front. These two down here. I've got the new 12 to 24 volt converter. This goes to the truck, and the way that that works is, let me back up a little bit here. I have this Anderson connector that will plug into the back of the bed of the pickup truck where I installed a port, and that'll feed up to 120 amps in down through this cable here. I do have it just on a 60 amp breaker, and what that'll do is that'll allow me to run 2 of these if I need to. I've got just the one for now, 12 volts in from the truck, and then 24 volts off forward to the positive bus bar that I have in there. This 4-gauge here comes from the opposite converter, the 24 volt to 12 volt, and this is what feeds all the 12-volt circuits on the rig. And so it goes into an 80 amp breaker, which provides protection for everything except, correction, it provides the protection only for the hydraulic pump, which is up there. So that goes to there. Now this skips the 80 amp breaker and then goes to this little bus bar here, which feeds 3 smaller breakers. This is all factory from Grand Design, but this is the start of the 12-volt system. This lower one here goes to the shutoff, which I did maintain that 12-volt shutoff. There's the back side of it that's got the key style shutoff on the inside, and what that'll do is that will kill power to the fuse box inside. So much more room up here. Don't think I'm gonna add too much else in the future for electronics. You know, maybe just one more of those chargers if I need it. But that gives me a lot more storage space. I can keep my portable generator up here. I may even put some shelves in here and kind of take advantage of the space that's available. Take a look at what we did in here. Now, if you remember, the refrigerator was running off of the power inverter. Actually, that circuit, which I think includes the TV as well, but since that was running off of the existing inverter, there was no breaker in here for it. And so I took that Romex that was plugged into the inverter and ran it in through the back of the circuit box here, or the breaker panel, and I added a 15 amp breaker on the end. There was previously just a block off there, but it's actually already labeled for the refrigerator and everything. So all I had to do was add a breaker to that existing opening and run that line in through the back of this. So this is just about ready to go back together. I want to show you what I did for the power that goes out from the Multi-Plus to the breaker panel in the RV. So the cable wasn't long enough to reach all the way there. So I added this rail mounted set of Dinkle connectors, put them inside the box, and the added benefit to this is that I can double the input to this. I can do 2 Multi-Plus in this one side, and you can see all the extra connectors there. So when I do, if I do upgrade to a second Multi-Plus, I just run that AC from the second Multi-Plus into here, and it will combine into a single output out to the panel. I'll do the same thing if I add the second Multi-Plus on the input side. I didn't need it this time because I had enough cable length from the Power Watchdog, but I can add a second one of those so that I can split the incoming power into both Multi-Plus units. Let's walk through what we put together for the battery hold down. The lead time battery doesn't have any hard points or anything to just screw in directly to the frame. So what I did was I took these pieces of channel, drilled them top and bottom, bigger holes on top, and these are going to screw into the floor. Bigger holes will allow me to get the screw gun down through there. And then I've got another piece of angle that'll go across the top of the battery on top of just a piece of neoprene to cushion it, and then some threaded rod. So this is what it's gonna end up looking like. Pretty simple. There's a million different ways you could do it, but the lower brackets will definitely keep it from moving side to side, and shouldn't take too much tension to keep it held down and keep it from moving forward and backwards. We're up on the roof. We've got the solar panels laid out. This is roughly where they're going to go. I took up more space than I expected, but I've got room for, I don't know, maybe 5 more if we decide to expand this. So now that these are kind of roughly in place, I'll work on the bracketry, and actually before that I'll lay out the wiring, make sure that everything makes sense the way I've got them positioned. I have all the solar panels laid out and the brackets installed to the solar panel side. I added some neoprene foam underneath each one of the brackets to help seal to the roof. I'll show you what that looks like. It's just 1/8 inch thick, 1 inch wide, pressure sensitive adhesive on one side. So I've got them all laid out, got the wires roughly laid out where I want them. Now I'm just going to screw it down using stainless wood screws and sealing washers, and then I'm gonna lap seal over the top of everything. Here's what they look like screwed down. Probably would be pretty much leak free as is, just like this. But since I never want to have to mess with it or worry about it, I'm going to do the lap sealant anyway. And here it is with the lap sealant. It'll still flow out a little bit more before it dries, but you can see how that's pretty much going to make it impervious. Get to the back side of it, which makes me feel even better about using that neoprene underneath. Not that I expect a whole lot to leach in from the backside since it's underneath the panel, but that little cushion I put under there should really prevent anything else from coming through. One other thing that I did, when you take the cap off of the kind of the built-in solar prep, it was sealed with the cap on, so when that cap's off, there's some unsealed areas and some unsealed screws, so put a little extra lap sealant there. Now when we look in here, I did put the Victron control panel on here, so this will allow me to turn the inverter off completely or switch it to charger only. I can also adjust the amount of input power that it allows. So right now I've just got it plugged into a 30 amp outlet. This will ensure that it never pulls in more than 30 amps from that circuit. So say, for example, I turn on both air conditioners, the microwave and the toaster, it will only pull 30 volts in through the cord, and it'll make up, 30 amps through the cord, and it'll make up the rest on battery power. Here's the finished install in here. Two batteries bolted down. Here's our Multi Plus 2. It is a little noisy and it transmits some vibration through to the inside, but we'll see how that feels long term. I have to put some isolators on it or something. I did just throw a plastic cap over the front part of that positive bus bar, because each one of those screws that are sticking out of there is a hot 24 volts positive, and so just a little extra safety precaution there. There was an outlet screwed into the floor that the original inverter plugged into. That outlet was all busted up, so I went ahead and replaced it so I could continue to use the circuit that was here. And I went ahead and branched off of that to add a hardwired smoke detector under here, just in case something goes wrong. So that's it. I went ahead and kind of turned everything on, tested it. It'll run the AC off of the batteries just fine. The power assist works. I haven't had a chance to configure the Multi-Plus yet because you do need a special cable to do that, to go from the VE bus to USB. So I ordered that today. I was thinking that I could program it through the servo, but unfortunately that won't work. So I may not leave it on for very long until I can be sure that the battery charge settings are where they need to be. And speaking of servo, that's where I installed the Servo S. And so that just kind of pulls everything together. Also helps give me a readout of where the power's coming from and where it's going. That'll interface with a touchscreen in the future. Right now I just use a Bluetooth. Alright, so that's it. I'll show you one more modification that I did while I was in here before I put everything back together. Rather than have to unscrew the panel that was in here before, I replaced it with a piece of 1/4-inch plexiglass that's velcroed to the carpet on either side. And that'll allow me to, first of all, see what's going on in there. If there's a water leak or, God forbid, there's smoke or something, I'd like to be able to see it right away. And also I can get to it much faster, not having to unscrew that panel. And here you can see everything working. I've limited the power input because I just have it hooked up to a 20 amp plug, and so it's assisting and bringing in the additional power through PV and from the battery to cover the 1700 watts of AC load. One final thought on the solar: if you think you're going to get 1200 watts out of 1200 watts of panels, it's probably not going to work out so well for you. I've averaged far less than that, probably about 800, but just to show that everything does work the way that it's supposed to, we did hit a total of 1174 watts at some point. As we drove to the campground, there was enough direct sun to show that it really is 1200 watts worth of solar. Just don't plan on getting it all the time. Hope you found this video useful and informative. Click the like, subscribe, all the other click things, and thanks for watching.